Hi guys, today we're going to be looking at a question on work, energy and power. Question 5. The diagram below, not drawn to scale, shows a vehicle with a mass of 1,500 kilograms starting at a rest point A at the bottom of a rough incline. Point B is 200 meters vertically above the horizontal. The total work done by force F that moves the vehicle from point A to point B in 90 seconds is 4.8 times 10 to the power 6 joules. Question 5.1. Define the term non-conservative force. A non-conservative force is if the work it does in moving an object around a closed path is non-zero. So if the work done. Question 5.2. Is force F a conservative force? Choose from yes or no. Since force F moves the object from point A to point B, and the force is non-zero, as we can see that it is 4.8 times 10 to the power 6 joules. Therefore, this is not a conservative force. Question 5.3. Calculate the average power generated by force F. Since we have the work and we have the time, we can use the equation that power is equal to work done over delta T. We therefore have 4.8 times 10 to the power 6 over 90. And if we plug all of this into the calculator, we get 5.33 times 10 to the power 4 watts. The speed of the vehicle when it reaches point B is 25 meters per second. Question 5.4. State the work-energy theorem in words. The work-energy theorem is just a definition. And it's the total work done on an object is equal to the change in the object's kinetic energy. Question 5.5. Use energy principles to calculate the total work done on the vehicle by the frictional forces. Since they say use energy principles, we can say that W net is equal to a change in kinetic energy. W net would obviously be the work done plus the work done by friction, and the work done by the force. And this is equal to the change in kinetic energy, which is a half mv final squared minus a half mv initial squared. We know that W done by the weight, W standing for weight, is equal to the mass times the gravity and cos of the angle. We know that the work done by the force is 4.8 times 10 to the power 6. We have the mass of the car. We also have the initial velocity and the final velocity. Therefore, the only thing we're calculating is the work done by friction. So we can say the mass, this being the work done by the gravity, 1,500 times by gravity, times by 200 cos 180 being the height that it goes up, this height over here, plus the work done by friction, plus the work done by the force applied, which we know is 4.8 times 10 to the power 6, is equal to a half m being the mass, which is 1,500. And since these are basically the same, it's just the Vf squared minus the Vi squared. So we can say Vf squared is 25 squared minus Vi squared, which is 0 squared, is still 0. And when we plug all of this into the calculator and rearrange, we should get W friction by itself, and that should give us 1.39 times 10 to the power 6 joules. And that's the work done by the total frictional forces. That's all for this video. Thank you.